Hi, it's Carly McAvoy. Today I'm talking about multiplying and dividing fractions. So let's get started. When I multiply fractions, I want to reduce before I multiply if I can, and not just reduce at the end like a lot of students do. But in this first one, I have 5/9 times 7/4. And for multiplication, I just multiply straight across to get my answer. So 5 times 7 is 35. I can't reduce anything here. There's nothing in common. So all I have to do is multiply. 7 times 5 is 35. 9 times 4 is 36. And that's it. That's my final answer. Take a look at your calculator. If you do 5 fraction 9 times 7 fraction 4, and hit enter, you can get 3536 on your calculator and check your work that way. In the second problem though, instead of just multiplying straight across, I have a y in there. Doesn't change the rules. I'm just multiplying with a y in there. But I can cross cancel because I know that 5 goes into itself one time and it goes into 100 20 times. So that just makes my number smaller that I have to multiply with. I also can see that 32 goes into itself one time and it goes into 64 twice. So I can do that as well. Now when I multiply across the top, I have 1 times 2y, which is 1 times 2 is 2, and the y just comes along for the ride. And then on the bottom, 1 times 20 is 20. What happened? I can't leave that answer that way. Why not? Because 2 and 20 have a common factor. So right here I could have recognized, oh, I still have a common factor in my numerator and denominator. If I didn't recognize it then I'll do it now. I could say 2 goes into itself once and it goes into 20 10 times. And so I end up with 1y, and you don't have to write the 1 in front of the y, but you can. It's not necessary. It's assumed that we have a 1 there, even though we don't show it. So 1y over 10 can just be written as y over 10. And in algebra and math in general, we want to be efficient when we can. And so do we in English. If somebody says, how old is your son? You don't say he's 1 times 7. You could, but it's not necessary. 1 times something is not needed to be said. We can just say he's 7. Okay, let's take a look at number 3. We have 3 terms we're multiplying. Instead of multiplying across and getting huge numbers, I want to see if I can make these numbers smaller by reducing cross-canceling. Anything on the top can cancel anything on the bottom. So let's start by saying the obvious one to me is 10 goes into itself once and it goes into 30 3 times. I like that one because it's just easy and kind of obvious. 16 and 13 don't have anything in common. What about 16 and 32? Well, 16 goes into itself once and it goes into 32 twice. So yes, that can be reduced. Anything else? Well, actually, yeah, because there's a 27 on top and a 3 on the bottom. And that's what I didn't do back here, and I had to do it at the end. I'm not going to let that happen again. So I'm going to say, wait a minute, 3 goes into itself once and it goes into 27 9 times. Now I've canceled everything in there. Things can be right next to each other or all the way across from each other, but one has to be on the top and one on the bottom for that to work. So now I'm going to multiply across the top. 9 times 1 is 9. 2 times 13 times 1 is 26. And that's my final answer, having cross-canceled whenever I could. Let's take a look at something like number 4 when you have 1/4 to the 3rd power. You can do that on your calculator. I'll show you how. But this is what this means. 1/4 times 1/4 times 1/4. On the top, 1 times 1 times 1 is just 1. On the bottom, 4 times 4 is 16 times 4 is 64. So that would be 1/64. Let's take a look at on your calculator. There's no real reason that we need to have parentheses around that 1/4, but I'm going to, so it matches my problem and I'm confident that I didn't leave off something important. 1, and then the fraction button, and then the 4, and that is to the 3rd power. I'm going to use this caret button. Caret button to the 3rd power is 1/64. Yes, I got it right. Okay. What about for number 5? It's a division problem. When you're dividing, you have the extra step of flipping that second term. You never flip the first one. That's still going to stay as 5/8. I'm going to change division to multiplication, and I'm going to flip 3/4 to be 4/3. Now I'm going to cross cancel because I can. I can see that 4 goes into itself once, and it goes into 8 twice. And now if I multiply across, I get 5 times 1, which is 5, and 2 times 3, which is 6, and I get 5, 6. I don't know why I circle some and not others, so I'm trying to be consistent. Okay, number 6. It has variables in it, but it's the same idea. We're going to flip the second term, cancel what we can, and then multiply. So what I have to start with, I don't change the first term. I change the division into multiply, and I flip that second term. And then I'm going to do something else on this one to help you see what's happening. I'm going to write x squared as x times x. That's what that means, right? When you have something to the second power, it means you have 2 of them, right? Notice that the 5s, when I flip them, I can't cancel them now because they're both on the bottom. In fact, the only thing I can cancel here is one of the x's. 1x on the top and 1x on the bottom. So what I have on the top is 1 times x, which we saw before. When you have 1 times something, you don't need to show the 1. But if that's useful to you, I won't take off for it at this point. 1 times x. On the bottom, 5 times 5 is 25. And I'm going to write that as x over 25. That's the most, you want to be with the in math crowd. That's how I want you to write it. Okay, let's move on and do a couple more, and then we're going to be done. Okay, so we have 17y squared over 24x divided by 13y over 18x. I'm going to flip that second one and change that to multiply, and this time I'm going to do this too right away. I'm going to write the y squared as y times y, and then I've got 24x. Change that to times, flip it, 18x over 13y. Okay, and now I can start to cancel whatever I can. What I can see is I have 1y on the top and 1 on the bottom that can go. I have 1x on the top and 1 on the bottom that can go. What about the numbers? Well, 13 and 17 aren't going to help me at all. But what about 18? I know 18, 6 would go into 18 3 times and into 24 4 times. So I can cancel that or cross cancel that. And now I'm going to multiply across. If you don't know what 17 times 3 is, use your calculator. Looks like 51 to me. And I still have a y on the top. And then on the bottom, I have 4 times 13. Again, if you don't know what 4 times 13 is, use your calculator. Looks like 52 to me, 52y. Now, you can't do the variables on your calculator, but I could do the fraction parts if I wanted. And I can just multiply straight across to help me. 17 times 3, yes, that's 51. 4 times 13, yes, that's 52. And then I wonder, well, could I possibly reduce that? This one, obviously, you really can't. But if you're not sure if it reduces or not, put it into your calculator, use your fraction button, hit equal, and if it reduces, it will reduce it. If it doesn't, it's going to say, yeah, you are already at the lowest, so you're done. Okay, number 8 says evaluate if you multiply xy and if you divide x by y. If you know that x is 8/9 and y is 1/4. So here I'm going to say my x is 8/9 times, that's what that really means, even though we don't see it, my y, which is 1/4. That's evaluating this one right here. On the other hand, the other one says, what if x was 8/9 and you're dividing by 1/4? So that's evaluating the second one. We want to just do a multiplication problem and then do a division problem. Here, 4 goes into itself once and into 8 twice. Multiplying across, I get 2/9. That's evaluating this one. But the other one, I have to rewrite it 8/9 times, and I'm going to write 1/4 as 4 over 1. And I'm going to multiply straight across and get 32/9. That's that one evaluated. Now remember, I don't want to change that into a decimal. I don't want to change it to a mix. I just want to leave it. I'd want to reduce it if I could, but it's already reduced, so I'm done. What about number 9? What if, when it says find 5/8 of 24? 5/8 of, this word means multiply. I want to take 24 and I want to multiply it times 5/8. I'm going to put a 1 under the 24 to make it look like a fraction. I could just do that on the calculator, 24 times 5/8. That's what I might do, but here's what I'm going to do. 8 goes into itself once, goes into 24 3 times, and when I multiply across, 3 times 5 is 15, and 1 times 1 is 1. Just the same way you wouldn't say your son was 1 times 7, you wouldn't say your son was 7 divided by 1. You wouldn't say the 1 at all, so you would just say 15. That was pretty fun. I hope you had fun.